Hey everyone, welcome back to the channel where we take complex coding problems and break them down into simple, clear steps. Today we'll be working through a classic problem, removing duplicates from a sorted array in place. I have encountered this problem many times and it's one of those that looks tricky at first, but with the right approach it's actually quite straightforward. Let's walk through it step by step. Imagine we are given a sorted array like this. Our goal is to remove all the duplicates we have in place. That means we can't create a new array. We need to work directly with this one. By the end, the array should look like this: 0, 1, 2, 3, 4, with the unique values appearing at the beginning of the array. The remaining element doesn't matter. We'll return the number of unique elements, which in this case is 5. I remember the first time I encountered this problem, I thought, okay, this shouldn't be too hard, but then the constraint made me pause. We're not allowed to use extra spaces and the solution has to be efficient. That's where two pointers comes in. Trust me, this approach will make the solution clear and elegant. So how do we solve this? We are going to use something called a two-pointer technique. It's a way of keeping track of two positions in the array as we iterate through it. The first pointer will point to the position where the next element should go. The second pointer will scan through the array, identifying unique elements. As j moves through the array, whenever we find a new unique value, we'll copy it to the position marked by I. By the end of our loop, all the unique values will be stored at the front of the array. Let's jump into C# code now and walk through it step by step. We'll be writing a function called remove duplicates that takes in the array sorted array and returns the number of unique elements. Alright, let's break this down line by line. We'll define a class called solution with a method remove duplicates that takes an integer nums as input. First, we check if the array is empty. If it is, we return 0 because there is no element to process. Here we initialize the variable I to 0. This is our unique element pointer. It makes the position where the next unique value should go. Next, we start our loop. The variable j starts at index 1 and moves through the array. We begin at 1 because we already know the first element is unique by default. Whenever we find an element at num j that's different from num I, we found a new unique value. At that point, we increment I, moving the unique pointer forward, and we copy num j to num I. Finally, we return I plus 1. Since I is the index of the last unique element, we add 1 to get the total number of unique elements. Let's walk through an example to see how this works in practice. Suppose we are given the array. First, we start with I equal to 0 and j at 1. Since I1 is equal to num0, there is no need to move I. We continue scanning. When j reaches index 2, we see that num2 is different from num0. So we increment I to 1 and copy num2 to num1. The array looks like this. We continue this approach, and by the time j reaches the end of the array, we moved all unique values to the front. The final array looks like this: 0, 1, 2, 3, 4. And there you have it. We have successfully moved all the duplicates from the sorted array and returned the number of unique elements, which in this case is 5. Notice now we didn't need any extra space. We did everything in place, which is the key part of this challenge. I hope this video helped make the problem clearer and showed you how the two-pointer techniques can simplify problems like this. If you have found this video helpful, be sure to like and subscribe for more coding tutorials. Until next time, stay focused and happy coding.